Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Daniel bin Muhammad Rehan. Today I will present to you about my topic for the final year project. My topic is evaluation of Spotweld failure model in radius to roof resistant test FMVSS 216. My supervisor name is Muhammad Hafizi bin Abdul Rahman. The introduction. Spot welds are generally used to join panels in the automotive industry and car bodies that contain hundreds of thousands of the spot weld. The fatigue resistance and durability are extremely important. The failure of some spot weld and joint in a vehicle body can result in unwanted noise and vibration inside the vehicle as well as a reduction in crashworthiness. Spotweld modeling is difficult because finite element modeling ignores many local effects like geometrical irregularities, residual stresses, material inhomogeneity, and defect caused by the welding process. Problem statement. Rollover is a vehicle crash that is very dangerous because this accident mostly tipping the vehicle turns over on its roof. Most of the accident in roof crash usually has higher death ratio than the safe ones. So the main purpose of the research to find the right spot weld failure model behavior to replace the spot weld failure that has been allocated in roof crash simulation in radios. The research objective. The objective is to optimize the material failure model available in the radius definition library comparable to the actual roof resistance test according to FMVSS 216 within 10% of error. Second one is to compare time to weight ratio SWR result between current FE model and updated spot weld failure model. Scope of research. The scope first one is to use Altec Hyperwork as a medium in converting the finite element of the Chevrolet Silverado model from LS Dyna to RADIOSS format in order to run a crash simulation. Second one is to describe the parameter setup by FMVSS 216 that has been used in roof crash impact simulation and modified to the actual position car roof side during an accident. Lastly, to optimize the vehicle behavior and deformation properties that been analyzed from simulation. Literature review. Rollover are the most serious and dangerous crashes among all types of traffic crashes. The most vulnerable to rollover crashes are head and neck injury. Rollover have complex dynamic events and like other traffic accidents consist of the vehicle, human and environmental elements and their interaction. So in this project, we'll about real roof crash test. Real roof crash test has been widely used to evaluate the safety integration of vehicle structure, where there are specified standards such as FMVSS 208 and 216. Quasi-static simulation of roof crash remain the most difficult of these simulations. Frontal structure. The frontal structure are the critical part is A pillar. A pillar have the most absorbed energy impact in this accident. Crashworthiness structure design process is also called crash energy management (CEM) design, which aims to monitor load transformation path and optimize energy absorption. Side structural. Side impact has the chance of upper limb injury greater than frontal impact. The door beam should therefore be stiff enough to take the load on. The B pillar also takes up the load in case of side barrier effect. Roof strength crash test. Roof crash is a fatal accident that can lead to death. The strength of the roof is measured in the test by moving an angled metal plate down at a steady pace on one side of the roof and testing the force needed to crush the roof. The force exerted proportionally to the weight of the vehicle is known as the ratio of strength to weight ratio SWR. So in the roof crash test, the standard criteria is FMVSS 216. FMVSS 216 explains the test technique and equipment for quasi-static roof crash testing. Roof crash resistance norm in a freight car. This norm helps to mitigate passenger injury and death in rollover collision due to roof interference. Finite element Spotweld. Finite element Spotweld is the structure in the displacement field are difficult to solve by analytical method by the structural problem of domain that can be divided into large number of small subdomains. Finite element Spotweld is the complex behavior that connecting elements such as pole and weld joint that are making an important role for the comprehensive dynamic. Effect of Spotweld failure. Rupture of a Spotweld can occur prior to the failure of the base meter due to abrupt change in the impact load of one part after it joins. The resulting deformation tends to be significant. The impact load of an automobile body is often shifted from one part to another after a Spotweld fails. This phenomenon reveals large discrepancies between simulation and experiment. The failure criteria had been derived using the failure strength of the Spotweld under combined loading conditions. Quality Spotweld. There are two types of quality Spotweld. The first one is qualitative manner. Spotweld quality identification in a qualitative manner can be described as flawless Spotweld without any manufacturing defects. The second one is quantitative manner. The load-bearing characteristic of the manufactured Spotweld can be described as the quantitative method of Spotweld quality in the identification. Spotweld failure test and analysis can be divided into two categories. The first one, estimate the strength of Spotweld and provide related failure criteria. The second one, estimate the fatigue life of Spotwelds. Types of Spotweld in vehicle. There are two types of Spotweld in vehicle. The first one is resistance Spotweld, RSW. RSW has become a widely used automotive sector technique because body-in-white automotive assembly due to its low cost and short cycle time, flexibility, and robustness. Spotweld plate is divided into three regions: a cylinder-shaped weld nugget, a heat effector zone (HEZ), and the base material sheet. The second one is friction stir Spotweld (FSSW). FSSW is a solid-state welding process that can be used to join structural components in an overlap configuration. Refill weld tensile strength improved by up to 30% compared to the keyhole weld. Type of Spotweld in finite element. There are two types of Spotweld in finite element. The first one is point-to-point, P2P. There are four different P2P for Spotweld modeling elements: C-rod, C-beam, C-bar, and rigid connector. The second one is area contact model, ACM. RBE3 is an element that connecting of nodes at the bearing support to single node on the rotating axis. Lastly is C-weld. C-weld is preprocessor that produce a shear that flexible with 12 degrees of freedom with Tomoshenko beam with two nodes. Material of Spotweld in vehicle. There are two types of material of Spotweld in vehicle. The first one is high steel strength, HSS. HSS has become usually widely in the automotive because they meet all the requirements: cost, good balance of low cost, lightweight, and mechanical properties. Height steel strength are defined as steel with yield strength from 210 to 550 megapascal. The second one is advance of high strength steel, AHSS. AHSS are important material in the automotive industry because they use the weight reduction. The strength property that distinguish the AHSS are roughly defined as yield strength 300 megapascal and tensile strength 600 megapascal. Strength to weight ratio. Ratio of the applied platen load to the vehicle cab weight. SWR is one way to measure the strength of a vehicle roof. Higher SWR value suggests a stronger roof with less occupant compartment instruction. The formula of SWR is equal to applied force divided by unloaded vehicle weight. Methodology. The strength to weight ratio SWR of the roof truss is the main target that need to be achieved. The method used in achieving the SWR will lead to a different result. The design process is such a trial and error process which depending on the selection of the initial design. The model selection that I'm using in my project is Chevrolet Silverado 2014 has been chosen as the actual model for the crashing analysis by using alter RADIOSS. Main reason in choosing this particular model is by considering the small number of nodes involved in the simulation compared to another model. Spotweld simulation parameter. The suggested approach for modeling roof crash occurrence provide analyze trade condition and provide absolutely low estimate of the lateral speed of vehicle required to roof crash. The first one, acceleration. Acceleration, the target is 1 millisecond. Cross-sectional force is 4 times by 10 power of 3. The lastly, energy discrepancy 0.12 times by 10 power of 6. Preliminary result. Preliminary result that I got, the first one, initial velocity. Initial velocity when the vehicle is upside down, the roof is in the road, is negative 13,470 millisecond. The second one is when the car is the roof car is hidden like this. Initial velocity is negative 11,944 millisecond. The energy discrepancy that I got from the previous study is 0.12 times by 10 power of 6. Acceleration is 1 millisecond. And lastly, cross-sectional force 4 times by 10 power of 3. Spotweld simulation parameter. SWR values from 1.5 to 4.0 appears robust. Vehicle roof crash has very little correlation with rollover crash injury risk when roof crash SWR is less than 4.0. Strengthening roof by 1 SWR will result in a decrease in major injury risk in rollover of around 20 to 25%. That's all of presentation for my final year project. Thank you.